I know, guys, that at the top, hi, Courtney. At the top here, guys, I've got a 5 and a 5. That tells me that I have like bases. And my like bases are being multiplied. So I'm going to keep my base. And I was just telling teacher Nels in the other class, every time my boys come, like I teach at an all boys school. So every time they come to my door, they'll knock on my door and they'll be like, ma'am, keep the base. And I'll throw a sweet at them. They'll just come and knock on the door. Ma'am, keep the base.
And then when you do exponential equations with them, you have to drop the base. So what's going to happen then? Because they have to drop the base.
They will learn to drop the base. They will learn to drop the base. See, I have like these tiny sweets. So every time they're like, I need a sweet in my life, they come past my class and look at me and they're like, ma'am, keep the base. And then I throw them a sweet. Okay, so over here, I know that I have like bases being multiplied. I keep the base and I add my exponents. So I will have x plus x, and Zoom user, you are awesome. I just need your name, please, Zoom user. So this will give me 2x. And at the bottom, hello, Amy. Hi. Okay. Oh, Amy, it's so good to see you back with us. Been a while. All right, I'm going to rewrite 25, guys, with the same base as this. So I'm going to rewrite it as 5 to the power of 2. 5 squared. And then I need to multiply that by that x that was still there. So 5x to the power of 2, 5 to the power of 2x. Now, 5 to the power of 2x divided by 5 to the power of 2x, that's going to give me 1. So for those of you who got the answer 1, give me a thumbs up in the chat. Let me see if you actually did get a 1. And let me see how many of you guys got this one correct, because I wanna celebrate with you guys. Well done, David. Oh, Brianly, be careful. There are a couple of things there that we need to do. See, Mirula's even bored. Mirula's bored because he's like, yeah, easy. Liche's like, what question did we get? The one on the screen, Liche. Excellent. I'm getting a lot of thumbs up. I'm glad. This is an easy one, by the way. All right, I'm going to show you guys quickly. I'm going to show you guys quickly how we can possibly solve this question another way. So there's another exponential rule, guys, that says if I have x to the power of 5 multiplied by y to the power of 5, if both of these have the same exponent, if they have the same exponent, I can actually rewrite this as open brackets x times y all to the power of 5, which is in essence the same thing, because I can still distribute this 5 back to the exponents and I'll end up with x to the power 5 and y to the power 5. It's the same thing. I'm doing the same thing. Okay, now what I'm noticing over here up top, I notice that x, 5 to the power of x and 5 to the power of x, they have the same exponent, just like these two have, just like x and y over here have 5 as a same exponent. So I'm going to rewrite this as open brackets, 5 times 5, all of that to the power of x, which is still the same thing because I can still distribute. Okay, all of this over 25x to the power of x. Okay, now I know inside here, 5 times 5 is going to give me 25. So on the top, I'm going to end up with 25 to the power of x divided by 25 to the power of x. And this is equal to 1. Like the other one. Ta-da! Maths is amazing. Maths is cool. Yo, ma'am, how did you do that? Magic. Okay. Pretty cool. So your answer was correct. You can do either one of those methods. Your answer must come up as 1. Tiana's like, it's not make sure. It is 100% make sure, my girl. We got this. It's not that difficult, my sweetie. Okay. We're just trying to put the things together. Yes, Tiana.
Ma'am, so like if everything is like just gonna add up to 1, like what's the use? How much marks are we gonna get for it?
2.
Only 2, sure.
But Tiana, what if you're sitting at 78% and you need this? Come on, get the easy stuff. Get the easy stuff so that when the hard stuff comes by, we're ready for it. Okay. No stress. No stress if you're a little bit late, Liabona. It's great to have you with us. Murula, okay, Murula, you need to behave because I need a lot of people to just like understand what's going on. The first method that I used was prime factorization. Yes, we could say that. Yes, okay. Okay, we could say that. But guys, remember, if my exponents were like 5 to the power of x plus 1 times 5 to the power of x, this rule would not work. Okay, this rule wouldn't work because I've got x plus 1 over here, and over here I've got x. I need to make sure that my exponents look exactly the same. This rule will only work if this was also x plus 1. Okay, it doesn't work if my exponents look different. My exponents must look the same. All right. Okay. All right, let's look at number 2 quickly. All right, I've got an exponent. I've got a bracket and an exponent. I'm going to multiply these two. Somebody tell me in the chat, what am I going to do with this 16? How am I going to rewrite this 16? Oh, not 4 times 4. Remember, Bikukro, I wanted to have a base similar to all the others. Good. 2 to the power of 4. 2 to the power of 4. And then I need to multiply with that x that was there still. 2 to the power of 4x. That's it. Excellent. Okay. Buitepo 8 squared is 64, not 16. You're multiplying instead of doing powers. Be careful, be careful, be careful. Okay. Now over here on the top, I've got like bases being multiplied. So I'm going to keep my base there. I get a suite for myself. And then I'm going to add exponents. 4 to the power of 2 to the power of 4x. 3x plus x will give me 4x. Mbali says, ma'am, can you say 4 to the power of 2? Yes, we can, Mbali, but that's not going to help us because if I say 4 to the power of 2x, then I don't have like bases. I've got a 2 here and a 2 here, and then I've got a 4 here. So I can't compare bases. Okay, I need to make sure that all my bases look the same so that I can compare exponents. Okay, so if I do 4 squared, it's not going to help me anyway. All right, I need to make sure that all my bases look the same. Right. So now on the top, I've got 2 to the power of 4x over 2 to the power of 4x, which is also equal to 1. And I have a feeling Tiana's like, yo, ma'am, another 1. Ma'am, can they not give us something more original? Why are they always using 1, ma'am? Like, they must just give us like something different. They must just give us a... David, you're a whole rock star. Well done. That we've got, guys. Number 1 over here. Right. In the Beninging, yes, absolutely. All right. So remember, guys, if I want to compare any exponents, what do I need? What do I need in order to compare exponents? I need the same what? What do I need? The same basis, David. That's it. Not even like terms. I need the same base. Like terms are going to be difficult because 9 to the power of a and 3 to the power of 2a minus 1, not the same thing. I need the same base. My problem here is that I've got a 9 here, and I've got a 3 here, and I've got a 4 here, and I've got a 2 here. Nothing looks the same. Nothing looks the same. Okay. How can I make these bases look the same? Who's got an idea? Let me know. You can put it in the chat. You can raise your hand, have a conversation with me. Let me know. Mbali, not so much separate them. Tiana, that's it. We need a prime base. But for which numbers? Which ones am I changing? And what am I changing them to? That's it. Thank you, David. 9 to 3 to the power of 2. Good. So over here, I'm going to get 9. I'm going to rewrite 9 as 3 squared. All of this multiplied by 8. Don't forget. Don't forget. Times. How can I write 4? Witepo says 4 to 2, but Witepo, you're missing something very important. 2 to the power of something. It can't just be, I can't just replace 4 with 2. Okay, it needs to be 2 to the power of 2. That's it, David. 2 to the power of 2. And all of this is to the power of a minus 1. Yes, Tiana. Okay, this part isn't going to change to a minus 1. Do you want to unmute, Tiana, and ask your question for me, my sweetie? 2 to the power of 2a. Oh, no. Okay. Tiana, when you feel ready, you can unmute for me and we'll have a conversation. All right. So what happens next is I have a bracket and an exponent, and I can multiply these two. Now, the reason why I'm being pedantic about these brackets and exponents is because, guys, what's going to happen when I get here? I have a bracket and an exponent. This 2, is this going to multiply just a? Are we going to have 2a minus 1? Yes or no? What else needs to happen? I also need to distribute that 2 to negative 2, to negative 1. That's it, David. I need to distribute. Nondumiso, what's up? Okay.
We're gonna say 2a times a, 2 to multiply by a and give us 2, and then 2 minus 2 multiplied by negative 1 is going to give us negative 2.
Excellent. I don't want you to go away, so stay right there. Okay, so let's do this first part. I'm going to keep my base. My base is 3, and 3 is going to become to the power of 2 times a will give us
2a.
Excellent. Multiplied by, keep my base, don't forget my base. And then what happens over here? 2 to the power of?
2 to the power of minus 2a, I think.
Start from the beginning. 2 times a is?
2a.
Good. And then 2 times negative 1 is?
Is minus 2, negative 2.
That's it. That's it. Don't forget the part. Okay. That's very important. So distribute properly. Nondumiso, did that beautifully. Thank you so much, Mr. Excellent stuff. All right. Okay, let's continue, guys. At the bottom, I've got 3 to the power of 2a minus 1 multiplied by 2 to the power of 2a. Now I have like bases being divided. Oh, I almost said like bases being distributed. Like bases being divided. Okay, so I'm going to keep my base and I'm going to subtract my exponent. So Tandukolo, be very, very careful. Okay. Be very careful with that. Okay, this is what we're going to do. I'm going to take the top minus the bottom. So I'm going to go 2a minus 2a minus 1. Because I'm minusing the thing, top minus the bottom. So I need to make sure that I'm writing it correctly. I do need to close this. This isn't going to help us. Multiplied by 2 to the power of the top, which is 2a minus 2, minus the bottom, which is 2a. Okay. Does anybody know why I put this part over here in brackets? Who can tell me? Why have I put it in brackets? Write it a little better. Yes, Tiana, why would I put it in brackets?
I think men put it in brackets so that we can know that the 2a is going to be negative and the 1 is going to be a positive one.
That's it. Oh, amazing. That's it. Because we need to distribute that negative in. So I'm going to get negative 2a, and then a negative times a negative will give me positive 1. That's it, Hasna. You've also got your English there is not Englishing, but I understand what you mean. Hasna's like, because 2 is positive. And I'm not 100% sure what kind of math, what kind of English that is, but I get what you mean. Right. So over here, I'm going to get, Braden says, ma'am, why do we need to change the sign? Because, Braden, what is 2a minus negative 1? What's my answer actually? If I say 2a minus negative 1. It's going to give me I'm going to give me 3. It's definitely going to give me a plus here. That's it. I'm going to get 2a plus 1. Okay, because the negative and the negative will give me a positive. Okay, and guys, the answer is not 3 because these two things are not like terms. This one has an a, this one doesn't have an a. Okay, so my answer would just be 2a plus 1. Okay. Okay, now over here, I can then say 2a minus 2a is 0. So I will have 3 to the power of 1 left. And over here, I can say 2a minus 2a will give us 0. And I will have multiplied by 2 to the power of negative 2 left. Okay. Ma'am, why did you distribute the bottom powers to the exponents in Bali? Because there are no brackets at the bottom. Okay. Okay, there are no brackets at the bottom, so there's no need for us to distribute. That's it, David. You've got the right idea. That negative needs to then be inverted and go to the bottom. Okay, so I need to take this thing with the negative exponent, put it down here. So I'm going to end up with 3 over 2 squared, which is equal to 3 over 4. All right. Okay, all right. I hope that made sense. Okay, yes, Jasmine.
I got a question
Yes.
about the dot, right? What does the dot stand for?
It's times.
Okay.
We're multiplying. Okay, Zanoguche, what's up, my sweetie?
Hi, ma'am.
Hello, my sweetie. What's up?
Ma'am, may I please ask a question like this? How many months should it count for in a test or exam?
Probably 3, 4, maybe, if they're being nice. 4 marks in grade 10. The older you go, the less marks you get for things that you should know. So maybe 4 marks. But exponents is a very exponents is a very nice section to pick up easy marks if you know what you're doing. Okay.
Okay, thank you, ma'am.
Excellent. Nice question. Nice questions on everything. All right, Liche, do you have a question, my sweetie?
Yes, ma'am.
Yes.
I have to do like 1, 3. Like since we said 3 to the power of 1 times 2 minus 1, and then we had to like put what happens?
Sure, Liche, I'm hearing absolutely nothing, my boy. Like you were here, and then I feel like you took your speaking device and you did this, and now you're trying to speak to me, and I hear nothing. So I don't know. I can't hear you. Can I ask you to maybe type your question in the chat, and then I'll try and interpret because I can't hear you at all, my sweetie. I'm so sorry. All right. Okay, we're gonna have to think of something different to do this so I can actually get your question. Okay, so I want you guys to screenshot this one because this one works the same as the one we just did above. And Life says, oh, what happened to the 1? Anything to the power of 1 is just that thing. So x to the power of 1 is just equal to x. So 3 to the power of 1 is just equal to 3. Okay. All right. Dudu says, ma'am, how did you get 3 over 4? I still don't understand. Okay. So Dudu, remember anything with a negative exponent needs to be flipped. So it needs to become part of a denominator. And if it's in the denominator, it needs to become part of the numerator. Zesuliwe, nothing happens. You will still get your mark. Okay, you will still get your mark if you leave that there. So because it has a negative exponent, Dudu, I take it to the bottom. so that it can become positive. So this becomes 2 squared, and 2 squared is 4. That's where I got the 4 from. Okay. Hi, Tiana.
Hi, ma'am. So like, I have like a test on like Monday. Ne? So isn't there like past lessons of like the addition and addition and subtraction of fractions and stuff like this, but like with addition and subtraction of like last year maybe?
There is. Have a look on our YouTube channel from last year. Okay, go to the grade 10 section and you will have questions like that. Okay. Excellent. All right. I hope I'm saying your name correctly, Brianli. Okay, we can't multiply 3 times 2 because this is not 2, Brianli. It's not 2. It's 2 to the power of -2. If it was just 3 times 2, yes, by all means, multiply. But this isn't 3 times 2. This is 3 times 2 to the power of -2. So you can't just decide, I'm going to take 3 and multiply it with 2. That's not 2. That's actually 1/4. Okay, so we need to make sure if we're going to multiply 2 things that they both have like a power of 1 or something along those lines. Okay,
Even if you multiply with the negative still intact, you get the same answer. If you just say 3 times 2 to the -2.
Yeah, you can, you know what, guys? If you're having trouble with these kind of things, punch this into your calculator. Okay, calculator. Your calculator will give you the right answer. Don't stress too much. Okay. All right. I'm asking you guys to screenshot because I do need to move on to rational exponents and I've got something else we need to work through quickly. Take a screenshot of this. Geez, guys. I wish Amy had put this particular question or this particular thing she just told me in the everyone chat so that we could see that Amy is just crushing it at school, guys. She's getting like 100% and things. Mirrorless, like I did that once and my calculator broke. Yeah, I'll tell you guys a story at the end. Yes, this is also going to be part of the quiz tonight, Brayden. So that's why I need you guys to do it. Samuel, I'm going to ask you to raise your hand for me, please. Or there we go. Do you want to unmute and ask your question, my boy?
Hi, ma'am.
Hello, my boy. What's up?
Yeah, I wanted to ask if, let's say, the bases are the same, the bases are not the same, and the powers are the same. We multiply the bases, or we add the powers?
You multiply the bases and then you put them to the same power. So if I had, let's say I had 3 to the power of -2 times 2 to the power of -2. I can multiply these 2 and I keep the power. So I can rewrite this as 6 to the power of -2. Okay.
Yes, ma'am. Thank you, ma'am.
Does that make sense? Only if the powers look the same, okay?
Yes.
Excellent. Good question. All right. Okay. Now, guys, have a look at this question here. I know they call it rational exponents or something funky like that, but guys, we're not doing anything new. Okay. That's it, Tiana. That's what we have to do. That's what we're going to do. We're going to take 16 and write it as the product of its prime bases. What would 16 then become, guys? How would we write 16? We would write 16 as, if you're still having trouble figuring that out, guys, take your calculator, type in 16 equals shift, and then click fact. Okay, and it will give you the answer 2 to the power of 4. Try this. try this in your calculator, because if I have 4 to the power of 2, it's going to be a bit tricky. I need a prime number as a base, and 4 is not a prime number. 2 is the prime number though. So this is going to become 2 to the power of 4, a to the power of 2, all of this multiplied by 1 over 4. Now, again, we're just going to do the same things that we do when we have the normal exponents. I have a bracket and an exponent. I'm going to distribute. So distribute. So if you are uncomfortable with fractions, pick up a calculator and put the fractions in your calculator. What's 4 times 1 over 4? Ooh, let me not forget to put my base down. Keep my base. 4 times 1 over 4. Thank you. That's it. It's 1. So this is 2 to the power of 1. Thank you, Katlego. And then over here, I'm going to get a, my base a. And then I've got 2 times 1 over 4 will give me. That's it, Tiana, 1 over 2. And that's it. That's all I'm looking for. I'm done. That's the answer. Can I do anything more? Not really, unless I know that a to the power of a half is actually the square root of a. Maybe I can rewrite this as 2 times the square root of a. If I want to, it's not necessary because we are working with rational exponents. Okay, yes, we could go. That's it. That's what I was hoping to hear. Okay, let's look at down here. Over here, we're going to do the exact same thing, guys. Just make sure that you take 4 and you write it as a product of its prime bases. Okay. By the way, what are we going to rewrite 4 as? Amahle, teacher Nels, can I ask you to just reach out to Amahle? Her audio is not connected.
Okay.
Nondimiso, do you want to tell us, how can I write 4?
Two to the power of 2.
That's it, 2 to the power of 2. Amazing, young lady, well done. Okay. The person who's asking, why can we write it as square root? Because a to the power of half is equal to the square root of a. They're equal to each other. Okay. Yes, Jasmine.
Got another question, right? But
Yes.
it's not regarding this topic. It's about inequalities. Because
All right. Did you recently write a test on it?
I recently did an investigation on it.
Okay. Can I ask you, Jasmine, can I ask you to park that question and I will take it at the very end of the lesson? Okay, when you have time. Yeah. Okay, awesome. All right, so I'm going to get started here. I'm going to rewrite 4 as 2 to the power of 2, x to the power of 3, 4 to the power of a half. I already know bracket exponent, distribute, right? Multiplied by x to the power of negative a half over x to the power of negative 3. I already know that these things with the negative exponents, I'm going to switch them around. So this one with the negative exponent is going down, and this one with the negative exponent is going up. So we're going to switch them around. Okay. But I need to do this nice part over here first. So I'm going to have 2 to the power of 2 times a half will give me 1. And then I'm going to have x to the power of 3 times a half will be 3 over 2. Braden's like, why, ma'am? Because if I have anything with a negative exponent, Braden, if I have x to the power of negative 2, I put it over 1 and then I flip them. I switch them around. Okay. I can switch them around. All right. Multiplied by, this one is coming to the top, so this becomes x to the power of 3 over, this one comes to the bottom, x to the power of 1 over 2. Yes, Tiana.
Ma'am, must we leave it like in fiction form like this? Like,
Yes, yes. It's ugly, but it gets the job done. Okay. Don't shy away from fractions. And if you hate them, just put them in the calculator. Okay. Don't shy away from that. So over here, I've got 2. And then I see here that I've got like bases being multiplied. So I'm going to keep the base and I'm going to add exponents. So I'm going to have 3 over 2 plus 3, and that's going to give me x to the power of 9 over 2 over x to the power of a half. Now, I still have like bases being divided. Therefore, I'm going to get 2 to the power of my base x, and then I'm going to have 9 over 2 minus 1 over 2. That's going to give me 2x to the power of 9 over 2 minus 1 over 2 will give me 4. 9 over 2 minus 1 over 2 is 8 over 2, which is 4. Okay, so this is what our answer should look like. Then what did we do? What do we do with the 3 over 2? We have the same base, Amy, so we'll go 3 over 2 plus 3. If you punch that into your calculator, it's going to give you 9 over 2. We added them together. That's it, teacher Nels. Yes, we could draw. I do. I believe it. I believe you got this answer. You absolutely 100% did. All right. Last step again. Okay. See ya. Have a look here. Okay. I have like bases. I have the same base, and they're being multiplied. So I keep my base and I add exponents. So I've added these 2. Now over here, I have like base, and they are being divided. So I'm going to keep my base and I'm going to minus my exponents. And that's how I end up with x to the power of 4. Okay, I hope that makes sense, Sia. I hope that makes sense. Cecily, where you're getting the right answers, but you're like, yo, I'm learning a brand new language. Nah, it's okay. You're getting it right. You're doing the right thing. Don't stress too much. All right, let's have a look at the last thing we're going to be talking about today. All right, we're going to be looking at exponential equations. Now, remember we spoke about equations, guys, a while back, and we said that for an equation to be true, I have to have 7 is equal to 7. I need to make sure that both sides are exactly equal to each other. Okay, if I decide to go 7 plus 1 is equal to 7, that's a lie because I've added 1 on the side. This is not true. And if I add 1 on the side, I need to add 1 on the side so that I can get 8 is equal to 8. I need to make sure that both sides look exactly the same, okay? Or that they are at least equal to each other. So if I say 7 plus 1 is equal to 8, those two sides are equal to each other because they add up to the same thing on both sides. So I need to make sure that they look the same. Now, let's look at this question that I've got over here. It says 2 to the power of x is equal to 2 to the power of 5. In order for these two sides to be equal to each other, what does my value for x have to be, guys? X needs to equal to, it's not going to be 2. Remember, x is my exponent. 2 to the power of 5. Therefore, my favorite word in the whole world, therefore x is equal to 5. Ontatilo's like, what were you doing with the 7, ma'am? I was explaining. Sorry, I'm sitting in my classroom and somebody over there, I think somebody's coming through the side there. Sounds a little weird. All right, so my x must be equal to 5, guys. Let's look at number 1 over here. Yes, true. And I was getting to that. Mpo is like jumping the gun. Mpo's like doing my job for me. I was getting there, Mpo. Okay. Yeah, that was it. Exactly, David. It's so easy. Look at this one. I have 5 to the power of x is equal to 5 to the power of 2. Therefore, x must be equal to, tell me in the chat, guys, what must x be equal to? That's it, Liabona. That's it, Amy. Well done. Michael, don't think. No, it's 2. It's 2, right? Very true. Now, guys, let's have a look at this one. Let's have a look at number 2. What does x need to be? Okay, good. It needs to equal 3. Wait, let me skip some space. Sorry, guys. There are people walking by and they're distracting me. X is equal to 3. Okay, so for those of you who got to 3, this is probably what went through your mind. Okay, I've got 3 to the power of x. And if I want these two things to look the same, I can rewrite 27 as 3 to the power 3. And now the way these two things are equal to each other is if x is equal to 3. And that's how we got to the answer. And just as Mpho had said, right, just as Mpho had said, we quickly notice that I have the same base here, I have the same base here, I have the same base there, and 27 can be written with the same base, same base. So if I want to compare exponents, what do I need to have, guys? If I want to compare exponents, I need to have because you're telling the truth. I need to have the same base. That's it. Tiana.
Ma'am, but what
Yes.
if you like the one that's to the power of x, must you like also make it like the same base as the one? Because like if I question 4, I'm now seeing it's not making sure.
Which one?
Question 4. Okay, but let
Question
me wait till it comes there. It's okay.
Which one of this is not written as a prime base?
4 the x
Four.
is going to be 4. Okay, it's gonna be 2 to the power of 2, and then like is it gonna be in brackets then x to the power of x?
2 to the power of 2 in brackets x.
Is it like it, man?
Yeah. And then all you need to do is bracket and an exponent distribute.
Then it's
Yeah.
2x.
Can you take it from here? Does it make a little more sense?
Yes, ma'am.
Excellent. Okay, it's not difficult at all. It's not. Okay, don't stress too much. See, Samuel's like number 3, therefore x is equal to 4, because Samuel is like, okay, right. I need these two things to have the same base. So I'm going to turn 9 into 3. So I'm going to have 3 to the power of x is equal to 3 squared, because 9 was already to the power of 2. Okay, so now I've got a bracket and an exponent. I'm going to multiply these two. 3 to the power of x is equal to 3 to the power of 4. Therefore, x is equal to 4. Dumelo, you would have thought right. You thought right. Okay. Now, if you have a look over here, Tiana's already done the work for us in number 4, guys. So, no, Rita, not at all. Not at all. That would have been correct as well. Rita's asking, would it be wrong if we said 3 to the power of 4? No. Okay, not at all. Okay, Tiana's done some of the work for us here. I'm going to get 2 to the power of 2x is equal to 2 to the power of 8. And now that my bases are the same, I know that my exponents are the same. Therefore, 2x is equal to 8. I can easily solve for 8. I can easily solve for x. Divide by 2 on both sides. Divide by 2, divide by 2. Therefore, x is equal to 4. Easy stuff. Easy claps. All right. Yes, Tiana.
Can I help with like question 5 because it's like so nice.
Isn't it so nice? And they love asking it. I can guarantee you, if you write the question on exponential equations, they're going to ask you one of these. Okay. What do we know about one, Tian? What do we know about one? That anything to the power.
The power of 1 is like, okay, anything to the power of 0 is 1. So we're gonna say x is 0.
Thank you. So we're going to say 4 to the power of x is equal to. What is my base? I'm going to make my base 4 to the power of 0 because I know that anything to the power of 0 is 1. Therefore, my x is equal to 1. Ooh, yo, my x is equal to 1. Yo, ma'am, stop lying to people. Sorry, my x is equal to 0. Yeah, guys, it's about that time. Ma'am's brain is like, I'm like 5 to switching off. It's almost dinner time. Okay, all right. Let's have a look at number 6. Does anybody have an idea? Kwandokuthle, I need you to raise your reaction hand so that teacher knows, can we look for Kwandokuthle so that
Yeah,
she can help?
already I did.
Okay.
Yeah, there.
Ma'am,
Hello.
how are you?
I'm good, thank you. How are you?
Good, thanks. I just had one question on number 3, I guess. It says,
Yes.
but I did it in a very different way.
Okay.
What I said is, I changed 9. So in the calculator, it gives me the prime factors of 9 to the power of 2. And it automatically gave me 3 to the power of 4. And I didn't go the long way. Would I lose points on that?
No, you would not. No, you would not.
Okay.
Some
Thank you
people
very much.
do this. They
Yes,
would go,
ma'am.
9 squared is 81, and then they would change 81 to 3 to the power of 4. Even if you do it on your calculator, you'll get
Okay.
your marks. Okay.
Thank you very much.
You're very welcome, my boy. All right. Zanogile, do you want to help us with number 6? Do you have an idea?
Yo, ma'am, I'll be honest, ma'am. I don't understand anything that's going on. I'm gonna be honest. I'm so lost, man.
Okay. All right. Zanogile, have a look here. Do you notice how all the answers we've had so far all have the same base? 2, 2,
Yes, ma'am.
3, 4. Do you see that?
Yes, ma'am.
So our main objective, the one thing we are doing on all of the sides is we're just making sure that I have the same base on the left and the same base on the right. Okay, that's our job.
Yes, ma'am.
And as soon as we have the same base on the left and the right, my exponents then become equal to each other. Does that make sense?
Yes, ma'am.
Excellent. Okay, now Zanogile, don't go away. Okay, let's look at this. Do you know that if I had 2 to the power of negative x, let me not make it so obvious. Let me not. If I had x to the power of negative 2, what would I do to make that positive?
Once you put it over 1, ma'am.
So I would put it over 1, and then what would I do?
And then you take the negative exponent to the bottom.
And then the 1 goes to the top, yes?
Yes, ma'am.
So this would be 1 over x squared, correct?
Yes, ma'am.
Now, have a look at what I've given you over here. Right? And look at the answer you gave me over here. What can I do? I've got this, and I want to make this that. So what can I do here? I can take the 2 to the top, and my exponent will become?
Ma'am?
Okay, if I take this, if I take x to the power of 2, if I take it to the top, what's going to happen to my exponent? It's going to become?
It's going to become negative.
That's it. It's going to become negative. So if I take this 2 to the power x to the top here, it's going to become?
2 to the power of negative x.
That's it. So I'm going to have 2 to the power of negative x is equal to 8. Do you think, Zanogile, that I can write 8 with a base of 2? What would that look like?
Yes, ma'am. It's gonna be 2 to the power of 3.
So this is going to become 2 to the power of negative x is equal to 2 to the power of 3. Do I have the same base?
Yes, ma'am.
Absolutely. So as soon as my bases are the same, my exponents become the same. Yes?
Equal to each other. Yes,
That's
ma'am.
it. I'm going to have negative x is equal to 3. Can I then solve for x here?
Solve for
What's-
x. Wait,
Yeah,
yes.
what therefore x is equal to?
Wait, ma'am, please repeat what you just said.
I just need to solve for x because I've got negative x. I'm going to have to divide by -1, divide by -1. Therefore,
Yes,
x
ma'am.
is equal
To 3.
not 3. 3
Wait.
times -1.
To negative.
-3.
Yes, ma'am.
Do you see what we did there? I'm using the same maths that we used before. I'm just using it the opposite way around. Okay.
Yes, ma'am.
Okay. Maybe have a look at it again and just make 100% sure you're understanding where I'm coming from. Okay.
Yes, ma'am.
All right. Okay. Now Nondumiso says, I need help with number 7. And I can see there's been a huge debate in the chat about number 7. Right. Number 7 says 2 times 5 to the power of x is equal to 50. Guys, let me ask you, if I had said to you guys, 2 times x is equal to 4, what would you all do? What would you do to get the answer for x? Tiana, yes, Tiana.
When what was the question?
What would I do here to get the answer for x over here? I would
Change the 4 to make it, change the 4 to make it look like the 2 so that x can be 2. I don't know if I'm making sense.
In this case, I just have 2x. There's nothing in my exponents. It's just 2x is equal to 4. So how would I get rid of the?
It's like dividing it. Divide 2 both sides.
Divide by 2 on both sides. Therefore, x is equal to 2, right? Easy?
Yes, ma'am.
Now over here, I've got 2 times 5 to the power of x. How do I get rid of this 2 over here?
For are we getting rid of the 2? Then I can't help me because I did something completely different.
Okay, but I mean, if we follow the logic that we just used over here for 2x is equal to 4, wouldn't I just divide by 2 on both sides?
Yes, ma'am.
And then 2 divided by 2 will be 1. And then 50 divided by 2 would be?
25.
25. Can I get same basis from 25?
Yay! Yes.
Not that difficult anymore. You see. Excellent. Itemba, do you want to finish off the sum for us? Hi, Itemba.
Ma'am,
Yes.
I'm fine. Can I ask about number 6? When you got minus x is equals to positive 3, can you just say minus 3 is equals to x so that the x can be positive?
No, we can't, because originally our x is what is negative. So you need to do that extra step. You can't just make it up and say that actually x was positive and 3 was negative. No. You need to write it out the way it is before we give the correct answer. Okay?
Yes.
Okay, excellent. Don't skip that step. Can we? I've never seen it.
Yeah, you can. It's like you already transposed because you had negative x equals to 3. If you know that it's going to be negative x equals to 3, and then you transpose, take 3 to the other side and x to the other side.
Oh, is Itemba basically just switching them around?
-3 equals to x. Yeah.
Okay, so what she did was she did it from this step. From this step, she took that one that way and that one this side. Okay, Itemba, yes, that is allowed. The reason why I was saying no is because I thought she took it from here and she just made things negative. So, okay, that's why I was kind of like, we don't do that. Okay, but if you're taking it from that step, yes, 100%. I understand what you mean now, teacher knows. I didn't quite see it at that moment. Okay, Tiana, I would need to see that different method. Okay. Actually, there is a different method to answer that question. Okay, yes, Ashrimile.
So ma'am,
Yes.
you see for question what's this question? 8.
Yes.
So it says 1/4. And can't we like convert the 4
How would we do that?
like 2 to the power of 2 and then like and then
You onto something there?
ma'am,
Think about what you're saying, you're making sense. Think about what we did here. As soon as you make that 4 2 to the power of 2.
and then we have a negative x. Don't we have a negative x? And then
Not yet.
what? Okay.
Okay. I'm going to explain in just a bit. I need to finish this question over here. 5 to the power of x is equal to 5 to the power of 2. Therefore, x is equal to 2. Okay. Let's think about this, Ashimile. You've just said we're going to make 4 2 to the power of 2. Yes?
Yes, ma'am.
So I'm going to have, in my bracket, I'm going to have 1 over 2 to the power of 2 all to the power of x is equal to 32. Now, just the same as we did with this 1 over 2 to the power of x, if I take this number to the top, my exponent will become
A negative.
good. So I can rewrite this as 2 to the power of -2 all to the power of x is equal to
Okay.
32.
And then we convert that to the 2 to the power of 5.
That's it. So I'm going to have 2 to the power of, I'm going to multiply these two together. I'm going to have 2 to the power of -2x is equal to 2 to the power of 5. Can I solve for x from here?
Yes, ma'am.
See, it makes it a lot easier. Okay, if my bases are the same, then my exponents will be equal.
To cancel.
Got a 2, and then I've got -2x is equal to 5. Solve for x.
-2 or no, 5 over -2.
That's it. Therefore, x is equal to 5 over -2. Makes sense?
Yes, ma'am.
Excellent. I love this. Nelly's like, drop the base like it's hot and equate the exponents. Drop it like it's hot. Drop it like it's hot. Yes, Untatile, it's very possible. Okay, I want to show you guys another method that you can use to find the answer. Okay, for this one. Okay, let's do this. Let's do this. I can rewrite this. I can go 1 over 2 to the power of x is equal to 2 to the power of 3. Now, I'm going to take this part and I'm going to put it as 1 over. So I can take this and I can go 1 over 2 to the power of x is equal to 1 over 2 to the power of -3. So I can do this step the other way around, right? And then because these two have the same base, I can make them equal to each other. Then I can go, therefore x is equal to -3. Okay, I can do that as well. Okay, I can do either of those things. They both work because I'm just doing the opposite. If it's positive, if my exponent is positive over here, when I bring it to the bottom, it's going to become negative. Okay, yes, Courtney. We've actually run out of time.
Ma'am, actually, in question 7, I did a different method, but I still got the same answer.
Okay, what different method did you do?
Well, it's similar to what you have done, but just the same. I said was 2.5 to the power of x is equals to 2.5 to the power of 2. Since both of them have the same basis, therefore x is equals to 2.
Okay, hold on. Now, that's where we're going to have a problem, Courtney. And we need to remember this, guys. In mathematics, especially in South Africa, the dot means multiplication. Okay, if we're going to make something 2.5, we will literally say 2.5. We will not put a dot. A dot in South Africa means multiply. Okay, and if you punch this into your calculator, if you go 2.5 squared, your answer is not going to be 50. Your answer is going to be something like 6.25. It's not 50. Okay, so we need to be very careful. That dot in the middle, it's not a comma. It's a multiply. Okay.
Yes, ma'am.
Okay, be very, very careful, my sweetie. So we're not able to do that at all.
Thank you, ma'am.
You're very welcome. Okay, it's good that we're finding this out now instead of in an exam or a test. Okay, Kwando Kushe, what's up? Yes, Braden, teacher Nels can put the link to the quiz in the chat. We're already 4 minutes over and we do need to cut it off. Same Mirula, I also have to go. Hi, my boy.
Ma'am, I wanted to ask one question. No, it's not a question, but it's a request. May you please re-explain number 8? You're going a little bit too fast.
All right, I will slow down. And then after that, I really do have to go, guys. I'm on night duty at my school, so I need to go. All right. So remember this part over here, this one here, where we took 2 to the power of x, right?
Yes.
1 over 2 to the power of x, and we took this to the top, and it became 2 to the power of negative x.
Okay.
Yes. So I can change 4 to 2 to the power of 2. Do you agree with me?
Okay, yes.
So now I've got 1 over 2 to the power of 2, all of this to the power of x.
Okay, yeah.
Now, the same way I can take this 2 to the power of x at the bottom and make the exponent negative when you go to the top. What's going to happen to this exponent of 2? It's going to become negative.
Negative 2, yeah.
So I'm going to have 2 to the power of negative 2, but this whole thing is still to the power of x.
X, yeah.
Which is equal to 20, no, not 23, 32, sorry. Okay, 32, this is also 32. Now I have a bracket and an exponent, so I'm going to multiply these two things, yes?
Okay.
And my base over here, I need my base to be 2 so that I can compare them. So I'm going to take 32 and I'm going to rewrite it as 2 to the power of
5.
5. Good. So on this side, I'm going to have 2 to the power of negative 2 times x is negative 2x is equal to 2 to the power of 5.
5.
My bases are the same, therefore I can so negative 2x is equal to
5. Okay. Oh,
makes sense.
Okay, makes sense. Total sense.
Okay.
Thank you.
All right, awesome stuff. Guys, I'm so sorry. I do need to rush.